Hello, everybody. Welcome to another Holistic Health Hour Zoom call. We are going to go over the questions that were submitted, and I think we're going to get to most of them. So let's jump right in and get to these questions. And the ones that we had today were all on genetics. Okay, so the first question, since fads is highlighted, it is recommended to avoid omega-6. So if you have never had your genetics done with us and you're listening to this through the detox course or something like that, you're like, what in the world is this conversation about? So your FADS gene, your FADS genes, this is a family of genes that we're talking about. And when we do a genetic workup, we're going to also not only give you the full genetic results, but we're going to give you our summary of things to work on. And in this case, this person had a lot of defects on their FADS genes. And so therefore we highlighted that. And one of the recommendations is to possibly avoid omega-6 fatty acids. Well, the FADS genes have to do with digestion and absorption of nutrients. It has to do with your digestive system. And it particularly has things to do with your digestion of fats as well. So omega-6. So let's talk about the difference between omega-6 and omega-9 and omega-3 fatty acids, your main three different fatty acids that you're consuming. So omega-6 would be found in things like flax oil. Omega-6 is found in fish too, but fish is going to be much higher in omega-3s. Most of your seed oils are going to be very high in omega-6. Well, what do we consume the most of in our diet in America? Well, omega-6. Why is olive oil a better oil to use in cooking? Well, because it's more omega-9s. So omega-6 is not a bad oil, but there's a test that you could do. I think it's through Genova or something like that, where it measures your omega 3 to omega-6 ratio. And it's a good test to run because you can really see in your body the ratio of omega-3 to omega-6 and how it can be really off. And because you think we're eating a good diet, and yes, is flax good for us? Sure, flax is good for us. Is flax oil good for us? There could be benefits to flax oil, but it's very high in omega-6 fatty acids. And we tend to get way too many omega-6 fatty acids. So what about ground flax seeds? Well, they can have other benefits. Ground flax seeds also give you fiber and other benefits, but they are higher in omega-6 fatty acids. So remember, first of all, rule number one, when we look at your genes, just because you have defects doesn't mean you have major problems with that area. It just means that you could be prone to problems with that area. So that's rule number one. Rule number two is it's all about balance. So having a lot of FADS gene defects, you might want to just consider, you know, upping your omega-3s and your omega-9s and decreasing your omega-6s. So it's all about balance and to understand that. So FADS genes are dealing with fatty acids derived from triglycerides or phospholipids. These fatty acids are important fuel source, but the FADS genes affect your ability to absorb and utilize those. So it may be better to increase your omega-3s. Next question. Explain the APOE gene. I have one variant, E4, one yellow, one red, downregulated. So the APOE gene. So the APOE gene encodes for a protein that helps with the chylomicrons. Your chylomicrons help carry cholesterol and triglycerides and help you absorb cholesterol and triglycerides in your body. So that's so one of the things that APOE gene does is it helps you create those. It helps you deal with cholesterol and triglycerides in your body. So if you have a lot of defects in your APOE genes, then you have an increased risk of not being able to control cholesterol as well. And you have an increased risk, according to multiple studies, of having elevated cholesterol. Doesn't mean you do. So again, you look at your genes. Oh, let's say I have a lot of defects in the APOE gene, but then you do a cholesterol test. Well, my cholesterol is within normal limits. Okay, well, then don't worry about it. So again, this is your genes. It doesn't mean that is going to equate exactly to function. It has so much to do with other things, lifestyle, diet, and everything else that is tied to that. Next, when you look at APOE genes, this is this person's genetic profile right here. Here's the APOE gene. You only have a single allele defect on one of those two genes in that family. That gives you a -1 as far as a risk factor. So in the negative, the risk factor can be -1, -2, -3. If it was a -3, then it would be a much higher risk factor. So, and then if you look, whenever you look at your genetic test, the full results, when you see this percentage right here, this percentage, that means out of there's about 70,000 people that have done this particular genetic profile. Out of the 70,000 people that have done this particular genetic profile, 26.3% have a single allele defect there. Matter of fact, only 85%, that's pretty high percent, have no defect on this gene. That means 15% have some, either a single or double allele defect on this gene. So that's not if this was really low, meaning this was a really rare defect to have, then this could be a higher number, even though there's only a single allele defect on one of these two genes. This could be a -2. If this was a rare gene to have a defect on, it could cause more issues, has the potential of causing more issues. So in this person's case, I don't see even looking at this gene as an important factor whatsoever. The IL-13 gene, the IL-13 codes for creating IL-13 cytokines. So cytokines are different chemicals that are made in the body that are immune communicators. They communicate to your immune system to do different things. There's none that are bad. It's just that excess of some can be a problem. Now, with single allele defects in all of these genes right here, you think, oh, that's not good. But it still only gives us a -1 list here. And really, it's really not an issue. It's a +1, meaning including all the informational SNPs as well. So some of these aren't well studied. That's why that's the difference between an informational SNP and a more well-studied SNP. So really, this top gene right here is the most important of the IL-13 genes. If you had a 2 or a 1 on here, it would give you a lower number here, meaning it might give you a -1 or a -2 here. Step back a little bit. What does IL-13 do? Interleukin-13 is an inflammatory cytokine in a chronic inflammatory state. So IL-13 is made in a B cell or a Th2 response in your body. So in a sense, it's decreasing acute inflammation, but it's decreasing acute immune response. In a chronic situation, it's increasing chronic inflammation. And you typically see people with a lot of defects in their IL-13 that have issues with asthma, that have issues with mast cell function, that have a lot of skin rashes and dermatitis. You could look up numerous studies that are very well detailed about elevated IL-13 cytokines in acute dermatitis, people that are prone to skin dermatitis issues. They tend to react to detergent. They tend to react to, chemicals in their clothing. They can get rashes from it. They tend to be prone to rashes. So there's other issues too, not just genetics. But when we see a person that has a lot of dermatitis type issues, you want to look at their IL-13 genes. You also want to look at the rest of their histamine genes. So it's not just one thing. This is why it's so important to take a 30,000 elevation point of view when we're looking at your genetics. It's not just one gene. And you can't say, even if you had twos in here, that is the absolute cause of a person's dermatitis issues, though you could argue that it's a very strong possibility. So this blurb that stated, I just took this off of the full report so you can understand it, but I understand this is really for doctors. The IL-13 gene encodes for immunoregulatory cytokine produced primarily by activated Th2 cells. So this is a B cell response. So it's the B cell side, the Th2 side of your immune system that stimulates and releases IL-13. Though it can decrease acute inflammation because it decreases the Th1 response, it is still inflammatory, and it can cause that inflammatory skin issues, asthma issues, and things like that. So this person's question is, because I have these defects in my IL-13, these single allele defects, does this mean that I am prone to asthma? I don't have any symptoms. Well, yes and no. I mean, it tells you that you have some defects that you may want to consider cleaning up your environment. And that's the whole idea about looking at your genetics, is that it gives you clues to, boy, well, I could be prone just based upon this. Could I possibly increase ability to be prone to asthma or prone to skin conditions and things like that? Possibly. Maybe it's just going to be the impetus for a person to help clean up their life and clean up their exposure to chemicals and things like that. So that's how you want to look at genes. It gives you clues to lifestyle changes that can improve your lifestyle, because you don't want to have those issues. IL-13 also, just a side note, very common with skin conditions, very common with asthma issues, very common with inflammation of the arterial wall too. So atherosclerosis issues common with IL-13 elevation. Seems like I have issues with detoxing, but my PON1 and GST and catalase was not highlighted. This gives you another idea of exactly what I'm talking about. Maybe you don't have really any issues with your PON1 genes, any issues with your glutathione genes, any issues with the oxidative stress with catalase genes, but I seem to have issues with detoxing. Again, pointing us back to lifestyle is everything. So you're going to have issues with detoxing, and you're going to need to support detoxing if you have and had in the past a high level of exposure to different chemicals that puts pressure on the liver and have to deal with detoxing. So genetics is not everything. Genetics gives us clues to issues. So if you had, cytochrome P450, PON1 defects, a lot of glutathione defects, SOD defects, and catalase defects, you are going to have, a greater chance of having more difficulty in detoxifying. But you could have no defects in any of those genes, perfectly healthy genetically, detoxification pathways, but you're exposed to a lot more toxins than you should be exposed to. That's going to cause it. Or look at the neurology of detoxification. Go back to our 7 Phases of Detoxification book and look at the neurology of detoxification. The neurology is controlled by the parasympathetic nervous system. If you're living in a very stressful environment, if you have a horrible marriage, if you have a horrible job situation, you have family issues, whatever, you're not dealing with your stress very well, that's going to down-regulate neurologically your detoxification pathways, even if you had perfect genetics on your detoxification pathways. And let's say you weren't exposed to any more toxins than the average person, which maybe that's not a good example because the average person is exposed to way too much toxins. But let's say you were exposed to less, but now your detoxification pathways are only functioning at 50% because you're in sympathetic overdrive and your parasympathetic nervous system is suppressed. Well, that could be a cause of things too. That's why you want to look at your body as holistically as possible. That's why I'm so big in looking at your genetics, but you can't only look at your genetics. Hey, I'm big into let's do some tests on toxicity profiles, but you can't only look at that. I'm big at let's look at blood work, let's look at this, but you can't only look at that. You have to look at as many different pictures of your health as possible. And I'll tell you right now, lifestyle change and lifestyle modification is the key to overcoming all of this. All right. Well, thanks so much for another Holistic Health Hour. Make sure you get your questions asked. We'll be back in 2 weeks and answering more of your questions. Bye-bye.